Let's discuss row counts, timing, and blocking. Let's suppose we have architecture set up where we are comparing A, B, and C, different servers, different databases, but maybe let's say the same table. This could be, let's say, an ETL application where we're using a queue table approach and we're populating data from A to B to C, okay? Or it could be something like replication, anything that's sending data over. And what we're trying to verify is that data from A are ending up in C, okay? And by the way, it could be, we could add in more, right? We could say A, B, C, D, E, right? We could have 5 servers. So let's suppose that we're using an approach with row counts. There are a couple of different approaches for different architecture, but let's assume we're using row counts. Now, I believe in another video I brought up the fact that if you look at the row count by using .NET's properties, keep in mind that any committed transaction, right? In other words, it could be deleting rows. If that has not been committed, you do not know which direction it's going to be going in. In other words, it could be adding data, it could be deleting data. Until it's been fully committed, you don't know, right? You can do a count, you can do a hard count, but if you do a hard count, now you're going to create an issue with blocking. And I've seen this happen, okay? So I'm trying to verify data from A to B to C, right? Consider the most obvious problem with any approach that I use is going to involve timing, right? For instance, let's suppose that I know that C is going to be the last database or the last server to get data, right? Well, more than likely, C is going to complete with a, let's say, count star before A is. If A's having data loaded to it, right? Depends on the time, but more than likely that's going to happen. So if I try to check the row counts of A, the B, and the C, and data is constantly flowing, if C is the end result, more than likely it's going to finish faster. I mean, it's guaranteed that there's going to appear to be a delay from A to C if I do it that way, right? The other thing is what happens if A finishes, B doesn't finish for a while, and C finishes quickly. Okay, so let's look at this in T-SQL, a couple things. First of all, when we're looking at the .NET properties, let's look at this right as just an example. We're looking at this right here. And remember from the other video that I cover that this is not a hard read. And what I mean by that is this does not get the committed transaction. If there's a transaction in the middle of something that hasn't been committed yet, it could go either way, okay? This right here is a hard read. This select count star from application.dbo.mo historical data, that is a hard read, okay? This, if there are data flowing, if this hits before the data start to flow, I've seen this time and time again, this will create a block, okay? And I know people are like, well, you could always use with no lock. Well, yeah, you can use with no lock, but you're going to enter the same problem that you have with using the .NET approach, okay? When you build this process, whether you're looking for replication, ETL, whatever it is, to track from A to C, from A, B to C, right? Timing is going to be the biggest architecture approach of this, okay? If I expect my data to be flowing without very much delay. For instance, if I'm inserting batches of 1,000 at a time and I don't expect there to be a lot of delay, then I want my measurements of A, B, and C to be as close as possible. Okay? So if I'm going to use the count star approach, I would want to include time in when it was counted. Because if I don't include time, and I've seen this multiple times, where someone will build a process and I'll see A's time is 12 minutes different than C's time. And if I'm not expecting much delay in my data, well, then I haven't proven that at all. I mean, that if something finishes 12 minutes, let's suppose that the batch happens in A, within 60 seconds it happens with B, and within 60 seconds it happens in C. And I remember that's a batch of 1,000. What do you think the delay is going to be if there's a 12-minute delay? Right? So consider that. The reason why I prefer to use the .NET approach, even though it is not reading committed transactions, is because .NET is generally going to get, let's use A and B as an example, A and B very quickly close together, right? In other words, unless there's some type of network delay in that's a separate issue, but it's going to measure A and B very close at the same time. So if I'm not expecting that much of a delay between them, if I can say with heavy certainty that there's not going to be that much of a delay, then I'm measuring them, then my architecture approach is measuring them very close together, okay? I know that a lot of people like to call themselves architects because that's the high job title, but there's more to being an architect than calling yourself one. You've got to be thinking about these things when you're taking measurements. Timing is going to be one of the biggest keys here, especially if you have 3 or 4 or 5, right? Because how long is the delay typically with the flow of data? You need to be familiar with that. And if you are going to use the count approach, it's not a bad approach, but you do need to include the time, because the timing you may see on the report, oh, that's why. It's delayed because this actually finished 12 minutes after this one over here. Manually trying to do a time approach, in my opinion, is a very, very flawed idea. Okay, so I think that .NET is the best approach to it, to getting the .NET row count properties, but keep in mind that that is assuming that there shouldn't be that much of a delay between A to B to C.